Hi, welcome back. We're still here. So now we're going to talk about isosceles triangles. So we are going to find side lengths and angle measures of a triangle, and then we'll classify it. Okay, we're going to do some proof, and we're going to apply some properties. All right, here we go. Just to recap from our last video, an equilateral triangle has 3 congruent sides. An isosceles triangle has at least 2 congruent sides, and a scalene triangle has no congruent sides. Now, we also said that all equilateral triangles are isosceles. Okay, because 3 is greater than or equal to 2, which is at least 2, right? Okay. Classifying by angle measures. An acute triangle has 3 acute sides. An equiangular triangle has 3 congruent acute angles. A right triangle has 1 right angle. And an obtuse triangle has 1 obtuse angle. Okay, so those are our vocabs for classifying. All right, we have to find the side lengths and classify it completely. Okay, so what I see is that I have congruent tick marks on segment JK and segment LK. So I'm going to set those equal to each other and solve for X. So I know that JK, the measure equals the measure of KL. Okay, so I can substitute in and say 4x minus 10.7 equals 2x plus 6.3. Who made this problem up with the decimals? Jeez. All right, we'll be fine. It's fine. All right, so we have to add 10.7 to both sides. Oh, the decimals are going to go away. This is nice. It looked like they were mean, but it's nice. Okay, so I've still got 4x equals 2x plus a 0.3 and a 0.7 make a whole, okay? So I've actually got 17 over here because I've got 6 and 10 and then the whole from the decimals. So 17. You can check me on a calculator if you don't believe me. And then subtract the 2x from both sides, and I've got 2x equals 17. Okay, divide both sides by 2. And we get that x is, half of 17 is 8.5. Okay, so we know that x is 8.5. Now we just have to plug it in. I'm using my calculator for this. Don't judge. You know you're using your calculator too. All right, so for JK, I want 4 times 8.5 minus 10.7. 4 times 8.5 minus 10.7. Wouldn't it be cool if I was one of those people that could do that in my head? It would be so cool, but I'm not. 23.3. Even just thinking about it stresses me out. It's fine. It's fine. Those who can't do teach, right? LOL. All right, for KL, we got 2 times my x, which is still 8.5, plus 6.3, 2 times 8.5 plus 6.3. Oh, it should be the same thing, right? Because they're congruent. 23.3. It never hurts to like check it and make sure that they're right when they like should be equal to each other. You should get them equal to each other, plugging them into both. It's a good way to check your work. All right, let's plug in x one more time. 5 times 8.5 plus 2. 5 times 8.5 plus 2. I got 44.5. Okay, last but not least, we have to classify this thing. You know what would be really cool? Oh, never mind. I was thinking those were angles. Never mind. Forget I said anything. Classify it completely. Okay, so we know that it has two congruent sides. So it is isosceles. Okay, we've got this massive angle right there. Massive. So that would make this obtuse. You know what, guys? This thing might not be drawn to scale. I don't know that that's obtuse. We don't know. It's not marked with a degree measure. So I'm going to say that I was wrong to have put that, and we don't know this for sure. We don't know. With those side lengths, it is possible to figure it out, but that involves some stuff that you don't know how to do yet. So right now, you do not know. So you can't tell me it's obtuse. It is, though, but we don't know why yet. Okay. Next. It involves trig. Okay. Recall that an isosceles triangle has at least two congruent sides. Okay, we do remember that. I'm remembering that right now. I just talked about that. Recall that it's got two congruent sides. Okay, the congruent sides are called this is fun, it's called the legs. Legs. Okay. The vertex angle is the angle formed by the legs. That makes sense. The side opposite the vertex is called the base. Okay, so opposite means like across from. Okay, so that's this side. This one is the base. Okay, I'm going to label my legs too. This is a leg, and this is a leg. All right, the base angles are the two angles that have a base as a side. So this is a base angle, and this is a base angle. Okay, that kind of makes sense. Cool. All right, we have another pair of theorems. Got more theorems than we can shake a stick at. So this one is, these two are about isosceles triangles. So the first one is that if two sides of a triangle are congruent, then the angles opposite the sides are congruent. Now, if you're keeping track here, this angle A here would be the vertex because it is made up of the legs, right? So the angles that are congruent end up being the base angles. Okay, so if we have the congruent sides, congruent legs, okay, then we know that our base angles are also congruent. Okay, so we're calling it the Isosceles Triangle Theorem. I think I've also heard it called the Base Angles Theorem, but I might be making that up. So Isosceles Triangle Theorem, ITT. All right, so now we also have the converse. So the converse is just going backwards. Okay, this happens to be true backwards and forwards. So if we know that two angles of a triangle are congruent, those are these like base angles, okay, then we also know that their opposite sides are congruent. So opposite F would be this side, and opposite E would be this side. Okay, so if we have the angles, then we know the sides are congruent. If we have the congruent sides, then we know that those base angles are congruent. Oh, I tried to scroll on the computer. I'm gonna do this. All right, so look at this guy. We know that the length of XY is 20 feet. That's this right here. Okay, we have to explain why the length of YZ is also 20 feet. Oh, we can do this. Okay, so notice that they gave us this random 140 degrees out here. Okay, notice that the random 140 degree angle and angle YZX make a linear pair, and linear pairs are supplementary. So this little angle, can we call him angle, let's just call him angle 1 or 2, because 2 is easier to see than 1. Okay, the measure of angle 2 plus 140 has to be 180 because those two are supplementary. They are a linear pair. Subtract 140 from both sides and you get the measure of angle 2 is 40. Now, we got a 40 over here and a 40 over there. We got congruent angles. So if we have two congruent angles, then we know that their opposite sides are congruent. So, because angle YXZ is congruent to angle YZX. Using the converse of Isosceles Triangle Theorem. Using converse of Isosceles. Triangle Theorem. YZ is 20. And xy is also 20. xy equals yz equals 20. They're equal. Actually, that was here. Let's write it this way. These two are congruent, okay? Therefore, their measures are equal. So we'll say xy equals yz equals 20. Okay, that's better. That other way was making me feel itchy. I didn't like it. All right, so we got the base angles congruent to each other. So we use the converse of the isosceles triangle theorem. That means their opposite sides are congruent, and then their measures are equal. Ta-da! All right, let's do this one. Okay, we have to find the measure of angle F and justify each step. So I'm asking you for mathematical statements, and I'm asking you for justifications. So let's set up a statement side and a justification side. Statements and justifications. Also known as reasons. Okay, so first we have to tell everybody what we know. So we know a couple of things. I see that we have a known angle measure. So the measure of angle E equals 22 degrees. Okay, we also know that segment DE is congruent to segment FE. Okay, they are marked congruent, so we're going to write it down. Okay, and we know that because it was given to us. Okay, now what can we do with that information? Okay, sorry, I just had to gather my thoughts. I was on a roll and then the roll stopped. Okay, so because segment DE is congruent to segment FE, we know that this triangle is an isosceles. So we're going to say triangle DEF is isosceles. Isosceles. And we know that because of the definition of isosceles that we just talked about a couple of times. So definition of isosceles. Okay, next. Because it's isosceles, we can start drawing some conclusions about those opposite angles, the angles opposite to the legs. So opposite of that leg is this, angle F, and opposite this leg is angle D. And I know that they have to be congruent because DEF is isosceles. So angle D is congruent to angle F. Okay, and that is because of the, not the converse, but the original one. The Isosceles Triangle Theorem. Okay, Isosceles, we gotta see, Isosceles Triangle Theorem. Okay, next. Because they are congruent, I know that their measures are equal. So I know the measure of angle D is equal to the measure of angle F because of the definition of congruent. You thought you were done with the definition of congruent, but it's back. It's back. All right. So, we know some other good stuff. We know that the sum of the interior angles of a triangle is 180 degrees. That's important. So we know that the measure of angle B plus the measure of angle E plus the measure of angle F equals 180 degrees. And that is the triangle interior angle sum theorem. Oh my God, I feel like I've botched that title. That was on the first set of notes, darn it. Okay, we're gonna just go with it. Okay, triangle interior sum theorem. All right. Now, we're almost ready to start solving an equation with some math in it. I know you guys love it when we get to the math part. If you look at this, I have the measure of angle E. Ooh, let's use a color I didn't use already. Okay, look, I have the measure of angle E that I can plug in right here. I can make a substitution, okay? And I want angle F. I want to solve for angle F. I don't care about angle D, so I'm going to get rid of the angle D measure and replace it with an angle F measure because I want angle F. And I have a measure of angle F that I'm going to plug in for the measure of angle D. Okay? So the measure of angle D is just equal to the measure of angle F. So I'm going to put those in there together. Measure of angle F plus the measure of angle E is 22 degrees. 22 degrees. Keep the other measure of angle F equals 180. All right, let's subtract away. Ooh, forgot. That's the substitution property. Substitution property. Okay. Now let's subtract away the 22 degrees from both sides. So I have the measure of angle F plus the measure of angle F equals, what's 180 minus 22? 180 minus 20 is 160, minus 2 more is 158. 158 degrees. Okay, so we use the subtraction property of equality. Okay, we're almost there. Now, I've got two measure of angle F's. I'm going to substitute that expression for an equivalent one, which is 2 measure of angle F equals 158. I use the substitution property again. I think there might have been a way to do it in one step, but I think I had it earlier today, but my brain failed me. So it's a good thing I gave myself an extra line. All right, now we just have to divide both sides by 2. So divide both sides by 2, and we get the measure of angle F is, oh, my brain. 158, 92. I got 79. I probably could have figured that out if I thought about it. Okay, so we use the division POE, property of equality. All right, guys, I think that's it. So we were able to justify each of our steps using a whole rainbow of properties, theorems, and definitions. Fun. All right, next. We're going to do it again. We're going to make a flow proof. This one's half filled in for us. I know because I did it earlier today. Okay, so we have to complete the flow proof to find x and the measure of angle g. So we're given some information. Okay, first, we know that the measure of angle J is 3x. That is given to us. Next, we know the measure of angle G is x plus 44. That was also given to us. The last piece of information that we need to write down as given is that these two are congruent. So I can say segment JH is congruent to segment JH is congruent to segment GH. Okay, guys, this is just like the one that we just did where we're doing our justifications with our steps, but instead of going into columns, it's kind of going to be a fun little web, and we're going to figure out how they connect. Okay, so what does the definition of isosceles tell us? Well, if we have two congruent sides, then we know it's isosceles, so we know this triangle is isosceles. So triangle GHJ, GHJ is isosceles. And we know that because of the definition of isosceles. Okay, so we did not use the fact that we know the measures of these angles to get to that. We only used that these two are congruent sides to get there. So we only draw an arrow from that one. Okay, next. If we know that it's isosceles, then we can say that the opposite little base angles are congruent. So these opposite angles are congruent, angle J and angle G. And that is because of the, let's go back and look at what it's called. The Isosceles Triangle Theorem. Isosceles Triangle Theorem. Okay, so that came from this. Okay, if we know that they are congruent, then we know that their measures are equal. So I can say that the measure of angle J is equal to the measure of angle G because of the definition of congruent. Now, I know the measure of angle J, and I know the measure of angle G. That was given to me at the very beginning. So what I can do is substitute those in. So I'm going to substitute the 3x in and the x plus 44 in. Okay, and I'm using this last step because that gave me my setup for my equation, and I am substituting. Ooh, I need to write smaller. Substitution property. Okay. Everything is flowing together now. Okay. So I want to get all of my x's on one side. So if I subtract x from both sides, I get 2x equals 44. And I used the subtraction property of equality to do it. Last but not least, I divide both sides by 2. And I get x equals 22 by using the division property of equality. Okay, I have one final thing to do after I find x, and that is to plug in and find the measure of angle G. So the measure of angle G is labeled up here. Ooh, what happened? Is this. So I just have to take my 22, which is my x, 22, and add 44 to it. And I get 66. Now I am talking about degrees. So make sure you put your degrees, because we all know that if we forget the degrees when we need them, we're going to lose points. So if we're talking about angle measures, we need degrees, because we're not talking about radians. We don't even know what those are yet. 66 degrees. Ta-da! Cool. Almost done, guys. Did I connect my last bit of my flow proof? No, I forgot to connect. All right, I knew I was forgetting something. Okay, we went from the substitution property to this step, and then we went from that step to the division POE. Sorry, guys. The flow proof needs the arrows, and I'm messed up. All right, let's finish up. Okay, we have to find the specified angle, measure, or side length. So first I have to find the measure of angle H. Okay, well, if these two are congruent, these two sides are congruent, then I know that their opposite angles are congruent. So I know that 2 times the measure of angle H plus 48 has to add up to 180. Okay, so I'm using a couple of things here. I'm using my Isosceles Triangle Theorem. I'm using my sum of interior angles of a triangle theorem. I'm using a whole bunch of stuff. Okay, so subtract away the 48 from both sides. And we get 2 times the measure of angle H is equal to 180 minus 40 is 140. Take away 8 is 132. Divide both sides by 2 is I give up. 66. The measure, didn't we just get 66? Someone is messing with me. Measure of angle H is 66 degrees. Okay. Next. So this time we're given that the angles are congruent. So we have to use the converse of the isosceles triangle theorem. And if the base angles are congruent, then we know that their opposite sides are congruent. Okay, so that lets me set up my equation. So I have 8y minus 16 equals 6y. Just set them equal to each other. Oh, I want to set it up the other way. I don't know why I did that. 6y equals 8y minus 16. It doesn't really matter, except that it doesn't. Okay, so subtract 8y from both sides, and I get negative 2y equals negative 16. Divide both sides by negative 2, and we get y is 8. But I'm not done yet because I want to find MP. Okay, MP is this one, but it doesn't really matter because I could use 6y also. They're congruent, but I'll just plug it in where it says so I don't confuse anybody. 8 times y, which is 8, minus 16. So 64 minus 16, is it 48? 64 minus 16. 48! So the length of segment MP is 48. And we don't know the units, so we can just say units. Ta-da! All done. Okay, so that time we did use the converse because we started with the base angles and went to the congruent sides. So that was the converse. Let me write that down. Converse of isosceles triangle theorem. And then this one over here was just the isosceles triangle theorem. Isosceles triangle theorem. And we also used, to set up this equation, we used the triangle interior angle sum theorem. Whew. All right, now we're done.